Hello, this is Mrs. Peck showing you how to fill in page 7 in your notes for Unit 11. Um, Here we're introducing atoms into organic molecules that are not carbon or hydrogen. So we're going away from hydrocarbons. Introducing those different types of atoms increases the possibility of having different combinations, different structural formulas even more. So these other atoms, other than the carbon and the hydrogen, often provide the molecules with very specific chemical properties. So they provide a certain function. They are determining the function, and therefore they are called functional groups. So what we have to be able to do with them is determine their names, or if you have the name, being able to write down the formula. So we're starting here with naming these compounds. We will reuse some of the skills we've already done with the hydrocarbons, but we're also going to use table R. So if we look at the first example, this example has 2 carbon atoms and then a bunch of hydrogen atoms, but it also has an oxygen and a hydrogen in a row. So that is its functional group. Now if you switch over to table R and look at that and look for that functional group, you will find that functional group and the group that is called, a class of compound that is called alcohol. So that's the group. If we put it together with the rest of the molecule, we have a rest of the molecule here. That's right. And then that functional group, we get an actual alcohol. The example that you have listed helps you figuring out the name. So the examples has 3 carbons, and therefore we get the prefix plus. It has the alcohol group at the end of the molecule, so connected to carbon number 1 from that direction in, first all the way at the end, so that's where the 1 comes from. And then the fact that it is an alcohol is implied with the ending OL, so that makes a 1-propanol. If we go back to our first example, we had 2 carbons, so that will give us an F as the prefix. We also have an alcohol, so the ending will be, anol. F from the 2 carbons, and then ol from the alcohol. In this case, we don't really need to give a number for the position, because no matter where the OH group is, it's always on an outside carbon, because there are only 2, so each of them is on the outside. Okay, second example. We again have 2 carbons, so there's going to be something with an F in the name. But then we have a different functional group. The functional group in this case includes one of those carbons having a double bonded O and having a single bonded H. So we're going to have to look for that in table R. And we find that special group here. So we have an aldehyde. That means the ending is going to be Al. You may notice that there is no number there, because you can only have this carbon with a double bond to an O and a single bond to an H at the end of the molecule, because you already used up 1, 2, 3 of the bonds, so there's only 1 bond left for the carbon to connect to the rest of the molecule. which makes this an ethanol. Third example, we have actually two special features here. We have the straight line of carbons, which has 4 carbons, so that's going to be a bute something, butane something, because we have only single bonds. Then we have a regular side branch there, and we have the alcohol group that we already recognized from an example earlier. So the ending will be O, and that alcohol group is at an end carbon, so that will be a 1-butanol. The regular side branch still has to be named before that, and if this is carbon 1, then we have carbon 2, carbon 3, and carbon 4. As once we pick a numbering system, we have to stick with that. You can't just mix and match as we like. So then on carbon 3 is a methyl group. So we end up with 3-methyl 1-butanol. On the regions, you will rarely have a combination of these things. Like you either have a molecule with a branch or you have a molecule with a functional group. Okay, try the remaining 2 examples, or try the next example on your own, but I will go through the 5th example with you, as this is a little bit harder to figure out with table R. So we have a 2-carbon chain in the beginning that's interrupted by an oxygen, and then we have another 1, 2, 3, 4 carbons here as a secondary chain. So a special feature is that oxygen here in the middle of the chain, and we have another double bond oxygen. Let's look at table R. We find that under the ester, so we have 1 carbon chain which includes the carbon with the double bond O, and then we have a different carbon chain, and they're all connected with that double bonded O, single bonded O that makes the connection to the chain. How do we show that in the name? Well, this molecule really came into existence because an organic acid, I'll just look up here, this kind of looks like a little bit like it, reacted with an alcohol, which you already know on the from the top has an OH attached. Now when the two react and lose water, H2O, we have 1 oxygen left that makes the bridge, and the rest of the hydrogens and that 1 oxygen out of the 2 gets eliminated. Now, the main part that originally was the acid, that is making the second part, and you see the special ending there is an OH because it's like a salt from that acid. And the alcohol part is the front part, which is just named like a regular branch, but it's really just a regular attachment. Okay, let's take that back to our example. In our example, the acid part is the one that includes the carbon with the double bonded O. So this is the part that was originally the acid, and this is the part that was originally the alcohol. Okay, so the acid name, in this acid we had 2 carbons, so that would give us the prefix F for that acid name, and then we have the special ending anode. the alcohol part had 1, 2, 3, 4 carbons, so that would be a butyl ethanoate. Okay, so try that number 4 example and try challenge.